Laplace transform as a tool to solve the differential equation. And we define some ways and some signals that we need for our course. Of course, we mentioned last time, if you remember, we had also, we can call the table. And we have another tool today to use is the MATLAB. Since we are using our MATLAB as a tool, so we can use MATLAB in solving our equations or finding Laplace transform. Suppose we have a function like this one, f of t is equal to 5 exponential e to the exponential minus t. This one, we saw it before, it's the decaying exponential function. And according to your information, Laplace transform of this one, يعني المعلومات that we already took, it's simply 5 over s plus 1. 5 over s plus 1 is the Laplace transform for this. Let's have help for MATLAB. To start MATLAB session, we just call symbolic by typing sims ts. Sims means you need to start the symbolic engine. زي الانجن تاع السيارة for the car starts symbolic ts. T is the variable time domain and S is the S domain. So MATLAB will understand that they are your variable. And then you type your function like this. F, small f, is equal to 5 exponential minus t. EXP stands for exponential. So MATLAB will understand that this one is E. And then you type capital F is equal to Laplace of f. Laplace of f, and then MATLAB directly give you f, the green one here, is 5s plus 1, which is exactly the answer that you know already, 5s. So just use the function here, Laplace, and you are done. This will facilitate your life. It will make it very easy for you to calculate Laplace transform. So just symbolic, the first generate. رائد تفضل.
دكتور اذا استخدم طيب غير التي فاريبل هل راح يحولها للاس ولا لازم تي واس؟
هو he will consider whatever variable هنا you will put it, no problem. Just saying like this one, define at the MATLAB prompt, define your variable, any variable.
Yes.
Yeah, just symbolic like this one here. مثلا sims like this, sims رائد عبد العزيز علي قدور جعفر, or whatever symbolic variable, put your variables and that's it. Now we are defining t because we are dealing with time domain, and s because we are dealing with s domain, as simple as that. And you can define any variable. You won't change this variable, but you have to stick to this. 5 is exponential minus your variable that you are choosing here.
Yes.
Your variable هنا depends on what is your time. مثلا you want to call your time is العقيلي مثلا. 5 exponential minus العقيلي, it will give you Laplace transform for it. F is equal to Laplace of f. So the most important thing here is to remember these two things. Symbolic, to generate the symbolic function, this one, and then remember this. F is equal Laplace. These are the two important things that you should generate. This is how you define the function in time domain. F is equal 5 exponential minus t. And then f is equal to Laplace of f. And then you are done. Laplace, this is your function in time domain, and this is your function in s domain. Another example here, same thing in the same way. F of t will be minus 1.25 plus 3.5t exponential minus 2t, and then plus 1.25 exponential minus 2t. You define symbolic ts variables, and then you define your function minus 1.25 plus 3.5t exponential minus 2t plus 1.25 exponential minus 2t. And then f is equal to Laplace of f. MATLAB will give you this answer in time domain. Sometimes, Shabab, MATLAB will give you an answer that is clumsy. you cannot read it. متداخلة في بعضها. Just say simplify f, the expression that was given by MATLAB. You can ask him to simplify it for you. And still, if you are not happy with it, or if it's not clear to you, tell him, I want to have a pretty f. Pretty f يعني صورة جميلة. Okay? صورة جميلة, it will be given to you like this one. S minus 5 over S times S plus 2 square. And this will be your Laplace transform. So now, so far you have two tools. One is the tables. The other one is the Laplace. You can use these two tools. So far, Shabab, we have seen Laplace transform. But we need, at the same time, we need to have the inverse Laplace transform. The inverse Laplace transform, to know it, because we have a table, if you remember, we give you a table here. We give you one table. If you, for example, this, let me assume that this is my table. This is my function f of t, and this is the Laplace transform of f of t. We give you in the table for delta t, which is the impulse, Laplace transform is 1. For step input u of t, Laplace transform is 1 over s. For ramp input t, Laplace transform is equal to 1 over s squared, and so on. So you can go to your tables and see Laplace transform. Once you know, this is, of course, Shabab, once you know Laplace transform of f, means you will be able to know Laplace transform inverse. So here, Laplace transform when we go from time domain to s domain. So Laplace, I like this, I will write Laplace from t domain to s domain. Laplace transform inverse is to go from s domain to time domain, which is like this. So this one is Laplace, but this one, if we want to go back, it's called Laplace inverse. So now, if you know the function in S domain, you will be able, just by looking on the other direction like this, to the left. 1 over S is ut. 1 over S squared is 1 of t, and so on. So either we can use the table, this is what we are seeing here now, or we can use the partial fraction expansion. The partial fraction expansion is to bring the expression to a form that is easy to understand or that is easy to remember. I will show you through examples, I will show you how to use the partial fraction expansion, which is very easy. For example, it's very easy. We can write here an expression that is written as g of s is equal to, let's say, a over s plus z plus z1, let's say z1, a over, a over s plus z2. If we arrive to write our expression like this, this is b, Shabab, hina b. If we arrive to write the expression in this form, so Laplace transform hina is very easy. Laplace transform inverse g of t will be simply a to the minus z1t plus b to the minus z2t. So if we arrive to write the expression in partial fraction like this, 1 plus b, the inverse Laplace transform is easy. We will go through some examples. I will show you some also some cases, special cases. Here, they are asking us to find the inverse Laplace transform of this expression. F of s is equal to s plus 3 over s plus 1 times s plus 2. Here now we talk about the zeros of f of s. This is f of s. So the zeros of f of s are the value of s which make f of s equal to 0. This, if when f of s is equal to 0, this means that the numerator s plus 3 is equal to 0. This numerator is equal to 0. When s is plus 3 is equal to 0, we have s is equal to minus 3. That's fine. This is called the 0. So it has 1, 0. The poles of S, remember, Shabab, we have poles and we have zeros. The poles of f of S are the values of S that make f of S undefined, or that makes denominator equal to 0. The denominator here equal to 0 when these expressions S plus 1 times S plus 2 is equal to 0. When these ones are equal to 0, S is equal to minus 1, S is equal to minus 2, we call them real and distinct. Distinct يعني ما هم متشابهين مختلفين. They are distinct. So since they are real and distinct, we can write this expression in partial fraction. This writing called partial fraction. Partial fraction, this is the first fraction, and this is the second fraction. R1 over S plus 1 plus R2 over S plus 2. All the job you have to do is to find R1 and R2. What will be R1 and what will be R2? Once you are done, you found R1 and R2, it will be very easy to find f of t. F of t in this case, f of t will be very easy. It will be simply R1 exponential minus t plus R2 exponential minus 2t. So the pole here, this pole will become here, and this pole here too will become here. As simple as that. All the story is to find what is R1 and what is R2. In Math 202, you learned how to multiply this by this and this by this, you get this expression and solve equation. Here we have the easier way to find this one. Our expression is this one. Our expression is this, f of S equal to S plus 3 over S plus 1 times S plus 2, which is equal to R1 over S plus 1, R2 over S plus 2. Now, if we are looking to find R1, to find R1, Shabab, just say this. Forget about this and say cross product of this R1 times this amount is equal to S plus 1 times S plus 3. When S is equal to minus 1, لأنه البول هنا is minus 1. هنا pole S is equal to minus 1. So I will substitute this times this, S1 times S plus 3, S1 times S plus 3, over S plus 1 times S plus 2, and I substitute for the pole, لأنه البول هنا is equal to S minus 1. So I simplify S plus 1 with S plus 1, and I will end up by having S plus 3 over S plus 2. You substitute S is equal to minus 1. This will give you minus 1 plus 3 over minus 1 plus 2. Minus 1 plus 3, this will give you 2. 2 minus 1 is 1, so this one will be 2. This is R1. In a similar way, we can find R2. In solving for R2, we just ignore about R1. We just ignore about R1. So we will say, forget about this. And then R2 will be equal to S plus 2 times S plus 3 over S plus 1 multiplied by S plus 2. And I will substitute S is equal to minus 2. You simplify 2 and 2. See, Shabab, you simplify this pole, and it's the same when you substitute by this. So this will cancel. If they do not cancel, you will have problem here. Since we are canceling them, this is the way how to find it. You substitute, you end up by having S plus 3 over S plus 1. You substitute S is equal to minus 2, and you have minus 2 plus 3 over minus 2 plus 1 is equal to minus 1. And we are done. So now we substitute R1. تفضل يا هاني.
زاد فضلك يا دكتور. So here we just decompose it the fraction.
Yeah, this is we call it partial fraction here. We call it partial fraction to bring it to a form that we will be able to recognize. This is the first case. This is the first case. There are many cases. We are discussing them one by one. This is the simplest case. If you look, Shabab, we mentioned here, we mentioned in the previous slide that the poles are real and distinct. And here the title is the pole are real and distinct. So there are cases that we are going to discuss during this lecture and how to deal with each case. So just be patient and follow me step by step. So we found R1 and we found R2. We substitute R1 is this one, R2 is this one, and then you go to your table, and you will see this is simply a constant, so it is 2. So, or g of t, or if you want f of t, will be the inverse Laplace transform of this quantity plus the inverse Laplace transform of this quantity, like we are doing it here and here. So this is simply a constant 2, 1 over s plus 1. 1 over s plus 1 is exponential minus t. So 2 times exponential minus t here. And minus 1 is here. Exponential minus 2t, and this is known as the f of t, or the inverse Laplace transform of t. Any question for this one, Shabab? In the lab, we will see here the big burden, or the time consuming, is how to calculate this constant R1 and R2 called the residue. In MATLAB, or in the lab, inshallah, next week, we will see how we can use this command to calculate this residue. The function MATLAB called residue, we will see it in the class. Now, we are showing you just how to calculate by hand, because most of the time in the exams, or you will not have MATLAB maybe in front of you. So this is the way how to find it when we have real and repeated rule. I will repeat here. The poles are S is equal to -1 and S is equal to -2, which are these values here. These are real and distinct, مختلفين. واضح شباب? When they are distinct and مختلفين, this is how to do. This is the easiest way. Another example, شباب, obtain the inverse Laplace transform of this expression. S cubed plus 5s squared plus 9s plus 7 over s plus 1 times s plus 2. We know the poles here are s is equal to -1 and s is equal to -2. So these are the poles that make the value of the denominator. If you do this division, Shabab, if you this long division, you end up by having this expression plus this expression. This expression here, we just solved it in the previous example. This is previous example. There's no problem without it. And then we end up by having this to find Laplace transform of inverse of this and this one. You know, Shabab, Laplace transform of delta t, delta, the impulse, is equal to 1. Since Laplace transform of delta t is equal to 1, so the inverse Laplace transform of 1 will be equal to delta. So Laplace transform inverse of 1 will be equal to delta. So now I have a number multiplied by 1. So this will be 2 delta t. 2 delta t, صح ولا لا? Since Laplace transform of delta is 1. So the inverse Laplace transform of 1 will be delta. So this is the inverse Laplace transform of 2 will be 2 times 1, yani 2 times delta. Agree with that? Agree with that, Shabab? تفضل يا هاني.
Doctor, why here we have derivative? I understand the delta, but
you will understand it now. Just pay attention. Just try to concentrate, Hani. Try to concentrate with me. This is what we found. Now we found an expression like this. This is what's given. This was given. We did the division, long division. We found this term and this term. This term is the previous example. Previous example. Any problem with that? Previous example.
Yeah.
It's clear. Now we will deal with this.
Move, yeah.
Just why, please pay attention. Give me some time, please.
Take your time.
Now, Shabab, we have this S and then plus 2. How we can get this S? If you remember, now we define, first of all, we define Laplace transform of the first derivative, the derivative. When you take derivative, Laplace transform of x dot is equal to S x of s minus x of 0. Okay? Laplace transform of the first derivative will be is s x of s. I will repeat it in s x of s minus x of 0. واضح? This is the initial condition. It is 0 for delta. Which one, if I multiply, which function, that if I multiply it by s, and it will give me s. And this function, s x of s. What is x of s? S x of s. If I multiply it by, and then it gives me s. In this s, x of s is equal to how much?
1.
So 1. 1 is the Laplace transform of delta. This is it. This is it. This is why we are writing it here is 1. Laplace transform of delta is 1. So this is, it's the derivative of delta t. لأنه this one will give me s delta of s. S times 1. Delta of s is 1. So this is the derivative. In time domain, we will write it like this. And then this one is simply 2 times delta. 2 times delta. لأنه Laplace transform inverse is 1. واضح? So this is the, in general, Laplace transform inverse of f of s. But this one we already did it. This one is 2. You know Laplace transform of delta is 1. So this is 2 times 1. So the inverse Laplace transform is delta. And this is because of s. S need to multiply by 1. S multiplied by 1 is s multiplied by delta. So it's the derivative of delta. واضح؟ تفضل يا ناصر.
يعطيك العافيه. بس عندي سؤال بسيط. الحين اوجدنا s plus 2 by using a lengthy division or what?
Yeah. Just
okay.
divide by this. If you use MATLAB, just define the numerator here. If you how to find this one, I think they show you last lecture how into MATLAB how to find this division. You define the numerator, your numerator, you define it here. Sorry about the pencil is not writing. You define just your numerator.
Yeah.
And you define your denominator. And then you say the deconvolution. You used the deconvolution. Last time we used the deconvolution, and we will find the expression here.
Okay, thank you.
Let's go when we have the inverse Laplace transform, when we have a complex conjugate poles. Complex conjugate poles like this one. Then if you solve the denominator, the roots of the denominator here, if you use the partial fraction, or how to use the partial fraction, we need to find, first of all, to find what are the roots of the denominator. The roots of the denominator can be found like this, using the discriminant. You know how to use this one? And we found the root to be s is equal minus 1 plus or minus j2. So this one will give you s1 will be minus 1 plus j2, and s2 will be minus 1 minus j2, like they are doing here, they are showing here. This is s1 and this is s2. Now, Shabab, if we have this complex conjugate poles, it will have a special treatment. This is the way how do we deal with it. There is a complex method to do it, but I will show you a better method to do it with just completing the square. The second method is called the completing the square. If we have the denominator can be written like this in this form, s square plus 2as plus a squared plus omega squared. So this one, the denominator, we can write it like this, s plus a the whole square plus omega squared. So if we arrive to write this denominator like this, s plus a squared plus omega squared, and you solve, so you will have the two complex conjugate like this. If you solve this equation, this will give you s plus a the whole square will be equal minus omega square. You will say s plus a will be equal to minus 1 or minus j or j plus or minus j square root of omega square. plus or minus square root of omega square. You saw you were right. S is equal to minus A plus or minus J omega. This is the root. S is equal to minus plus or minus J omega. So if this is the case, this is how we deal with it. We just write the same expression before. We write the same expression here we have. Just pay attention, Shababa. Just pay attention here. What's going on here? Especially the denominator, this one. CS plus D. CS plus D, I can write it CS plus A. I'm adding CS plus A plus D. Because I am adding CA, I am subtracting this minus CA. So this and this will be the same. So I am adding A from here, AS, AC, and I am subtracting it from here, as if I have done nothing. So now I can split. I can say this over this. I'm writing it here, C S plus A over S plus A squared. This is one term. The second term will be D minus CA over S plus A the whole square plus omega squared. So we can do it this way. So I can say D CS plus A, this one, plus this one. Here, just pay attention, because I have this term here, I want to bring to a form that I can recognize. This is what I am doing here. بالنسبة للترم هذا, this term here, I am putting it here, D minus CA, but I am multiplying by the same number and dividing by the same number, so nothing will happen. Now, I brought it to a form that you can recognize easily. So this expression, this expression, it will be the inverse Laplace transform of this, plus the inverse Laplace transform of this one. Now, if you look to this one we have S square over S square plus omega square. This is because it is shifted, we have exponential minus AT, and this is a cosine term. So C times exponential minus AT cosine omega t. And this is D minus CA over omega, exponential minus AT, because it is shifted, A is shifted here, and then sine omega, because it's omega over S squared plus omega squared will give me sine. Okay, Shabab? So far, is it okay? So thus the tricky is, I added CA and I subtracted CA. And then it goes systematic. Is this clear?
Yes, clear.
Yes.
Yes, Sultan, what do you want? Please, tell me what do you want. شوف يا Sultan. Can you please pay attention here? And I don't know where the difficulty you saw it, but I will explain to you. And I did not want to give you this method, which is the complex numbers, which is more complicated. And I give you the easiest way. The easiest way is to complete the square, yani make the square easy. I will give you the example we had here. The example we had is simply 2s plus 12 over s squared plus 2s plus 5. Here, what we did, we wrote this one in this form, s squared plus 2s plus 5, s squared plus 2s plus 1. This 5, I wrote it 1 plus 4. 1 plus 4, this 4 can be written as 2 squared. So s squared plus 2s plus 5 can be written like this. 2s plus 12 over s plus 1 squared plus 2 squared. If you compare this to the equation I gave you, this is simply C S plus D over S plus A, the whole square plus omega square. So you can substitute A is equal to 1, omega is equal to 2, C is equal to 2, D is equal to 12, and we substitute the constant, and we will replace in the formula itself. The formula will give you this, which is exponential minus t cosine 2t plus 5 sine 2t. Can you please tell me where is the difficulty? Where did you find difficult? Just complete the denominator, complete its square, write it in this form. This is the form. CS plus D, we are writing it like this. We are writing it CS, we are writing it like this. We are writing it CS plus CA plus D minus CA. This is what I'm doing. Minus CA and plus CA, they cancel as if I have done nothing. And then I split this. This is alone here. And then plus this term, the second term is here. And then this one will be the inverse Laplace transform, which is known here. And this one we multiplied by omega and divide by omega, and we found. Just with the practice, you will see how it's easy. How it is easy. Now, Shabab, let's go, and then when we have repeated poles, يعني a pole in the denominator that is repeated, like this one here, s plus 1 cubed. Here, s plus 1 cubed, but it is repeated here. If we solve for the denominator, you will see that the denominator has a pole s is equal to minus 1, s is equal to minus 1, and s is equal to minus 1. We say that this pole s is equal to minus 1 is repeated 3 times, or it is a pole of multiplicity 3. How to find the partial fraction for this one? The partial fraction for this one can be written like this. We are writing it s squared plus 2s plus 3 over s plus 1. This is the original equation. We can write it in terms of a polynomial b of s divided by a polynomial a of s. And we write it in partial fraction. We write all the possibilities. We are writing b3 over s plus 1, 3. So 3 here correspond to 3 here, plus b2 over s plus 1 squared, plus b1 over s plus 1. So every exponent corresponds to indices. b3 s plus 1 cubed, b2 s plus 1 squared, b1 over s plus 1. Now the question is, try to find what is b3, what is b2, and what is b1. Because here, Shabab, we are dealing with multiple poles. It's not the same way. It's not the same way like we did it for the repeated poles. Now, just I want you to pay attention and follow me step by step. And if you follow me step by step, you will understand how we are going to deal with this. Now, if we multiply both sides of this expression here, if we multiply both sides of the expression E1, I'm writing here. So this is, if I call this one equation star, and remember this one, I can call it this one here. I'm talking about this term here. Now, if I multiply both sides of the above equation by s plus 1 cubed, both sides, هنا. S plus 1 cubed everywhere. Okay? Okay, Shabab? If I multiply by s plus 1 cubed, so this expression will be sorry, Shabab, my pen, sometimes I don't know how. So here multiply by s plus 1 cubed. Here s plus 1 cubed. Here s plus 1 cubed. So I simplify cubed with cubed, I end up by having b3 here. I simplified square with cubed, I end up by having this one here. I simplify s plus 1 with s plus 1, I end up by having this. Is it clear, Shabab? So we multiply by s plus 1 cubed both sides, from here to here. Did you get it, Shabab? Okay with me? Are you following? Both sides, both sides. Now, Shabab, if we multiply both sides, and I substitute this equation, I substitute s is equal to -1 here. If I substitute s -1 here, this will be 0, and this will be 0. And this will give me B3 is equal to this amount. So B3 will be equal to s plus 1 cube BS over AS when S is equal to -1. علي البشر تفضل يا ولدي.
دكتور نخلي S equal -1 بس في ال right hand side.
Yes في right hand side yes.
طيب تمام.
Yes. So we are looking for B3, we found B3. B3, this is how to find it. So B3 is the easiest one. Now, remember this expression. We need to differentiate both sides of the equation. Now we got this equation before. Now, Shabab, can you differentiate, if we differentiate this expression with respect to S, this one, if I differentiate it with respect to S. So this one will, if we differentiate it with respect to S, this will give me B2 plus 2B1 S plus 1. This is the right hand side. So this differentiation of this will be 0. Differentiation of this will be B2 plus 2B. And this one, when you differentiate it by, it's just put in a D over DS. So it means we are differentiating. واضح شباب? Is this clear? I differentiate both sides with S. B3 will disappear. And then I will find B2 plus 2B1 S plus 1. And then I substitute S is equal to -1 in the right-hand side. If you substitute S is equal to -1 in the right-hand side, this term will disappear, and you will find B2 will be equal to D over DS of this expression, which is in the next slide here. This is what we found. When we differentiate it, we found B2 plus 2B1 S plus 1. Take S is equal to -1. You will find B2. This is the expression of B2. علي البشر تفضل يا علي.
دكتور معليش ما فهمت الديفرنشيشن كيف طلعت B2 plus 2B1 S plus 1.
ركز في السلايد، ركز معي يا علي الله يخليك، ركز معايا. علي جاوبني انت. differentiate, can you differentiate this term with respect to S؟ جاوبني انت differentiate وقول لي. When you differentiate this with respect to S, what you will get? You will get 0. لأنه B3 differentiated with S will be 0 plus, when you differentiate this with respect to S, this will give you what?
B2.
Ali, differentiate this. So B2
معك B2
plus
plus 2B1
S plus 1
S plus. تمام
S equal. هذا خليه زي ما هو D over DS. D over DS.
طيب
Okay. This one, now substitute S is equal to -1. You will see what we'll get. This is what we will get here. If you substitute S is equal to -1 here, this term will disappear. And then you will have B2. B2 will be the derivative of this term with respect to S. واضح؟ واضح شباب؟ Is it clear? Is this clear? طيب. Now to find B1, شباب, we found B3 if you remember. We found B2. Now we need to find B1. B1, just differentiate this with respect to S. Differentiate this with respect to S. If you differentiate this expression with respect to S, well, this is what we will have. We'll have D over DS. This will be the second derivative. If you differentiate here at the left-hand side, it will be the second derivative. So D over DS. If you differentiate with respect to s, this term will be 0. And this one, when you differentiate it with respect to s, it will be 2b1. 2b1. Is that right, Shabab? This is what we will find. Here we are differentiating with respect to s. And then here we have 2b1. So 2b1 will be equal to 1 over 2. I wrote factorial because if we have higher poles or higher multiplicity, it will be factorial. It will be 1, 2, and 6, and so on. So this is why we are writing here 2 factorial. Because if you have more poles, it will appear as factorial. So this is b1, which is the second derivative of these terms. Now, if we apply these rules to this example here, if you remember our example, I will write it here again for you. We had, now we need to differentiate, we need to find the partial fraction of this, s squared plus 2s plus 3 over s plus 1 cubed, and we will do the same technique to find this partial fraction. Now we go step by step, like I showed you the method how to do it. B3, we need to multiply both sides by s plus 1 cubed, and then substitute s is equal to minus 1. When you substitute s is equal to minus 1, you will get, this is bs over as is here. This is it. Now substitute by s minus 1, you will find minus 1 squared plus 2 times minus 1 plus 3 is equal to 2. So B3 will be equal to 2. B2 will be the first derivative of this term when s is equal to minus 1. You take this term bs over as, you substitute it, which is this term. This is bs over as. And then you cancel s plus 1 with s plus 1 and take derivative of this term s squared plus 2s plus s with respect to s. This is, we are differentiating it here. You will find it's 2s plus 2 when s is equal to minus 1. This will give you 0. This means that b2 is equal to 0. b1 will be the second derivative over 2 factorial here of the same term, s plus 1 cubed times bs over as when s is equal to minus 1. You cancel s plus 1 with s plus 1, and you differentiate this one twice. You can either differentiate this one twice, or you can differentiate this one once. And this one is the derivative of the first derivative. So again, you differentiate the first derivative, you differentiate it another time, and that's it. You are done. So if you differentiate 2s plus 2, you will get 2. So 1 over 2 times 2 will give you 1. And then your partial fraction will be 2 over s plus 1 cubed over 0 s plus 1 squared plus 1 over s plus 1. The inverse Laplace transform, if you go to your table, you will find this one, because we have s plus 1 in the denominator, it will be e to the minus t. And then 2 over s cubed will give you t squared. 2 over s cubed will give you t squared. E minus t, because we have s plus 1. This one will be 0, and this one will be exponential minus t. This is when we have repeated poles, and the poles are repeated. Any questions, Shabab? You can also, Shabab, you find with MATLAB, you will find in the class or in the lab, you will find the function RESI2. We use the function RESI2 when we have multiple poles. Any question? Any questions so far? If you go to your notes, I already put the notes for this chapter on the comment section. The lectures will be on the comment notes. تفضل هاني.
Doctor, may I use the MATLAB for the homeworks and the exams?
Depending on maybe شباب هنا.
Because this is very lengthy.
خلاص, you finish هاني, you finish your talk.
Yeah.
طيب,
Yeah,
شباب, there is a question, I don't know if you are hearing from your friend, is asking if he can use MATLAB. MATLAB is a tool, and we want you to use the tool at the same time gain the skills. You should have some skills. لأنه if you use MATLAB as black box and sometimes you don't know how to use it, maybe MATLAB give you something is wrong. How to check it? Sometimes you need to check, so you need to have another tool in parallel with MATLAB to check. So we are giving you the skills and we are telling you these are the skills, how to use it, and then you can use MATLAB to check. Is the other way around. Use the tool, use the skills and check with the tool. Not use the tool and check with the skills. So sometimes in the exam, now it's not the general rule since it is online and we cannot check you or we cannot tell you do this with this. But if you usually the exam, when we ask you the exam, written exam, you have to do it by hand. And we are showing skills. Otherwise, what's the purpose of giving you these skills if we ask you to do it with MATLAB? So you should gain the skills, you should learn the skills, know how things are done, and then use the tools to make easy for you. You should know this. The usual way is to calculate it by hand and then check with MATLAB. You will see in the lab, we have a whole lab section devoted to Laplace transform, how to do both skills, gain skills with the hand and then with MATLAB. But usually, sometimes we ask you to do this with MATLAB. Sometimes we ask you to do it by hand. In the exam, we will ask you both. We'll ask you to show us your sheets, your analysis in the sheets, and you will be asked in the exam, show us your calculations or attach your calculations in the MATLAB. Is this clear, Shabab? Is it clear? I finished my lecture today.
كثير.
Yeah, okay, shukran. And it's very easy because this is not new for you. I think you saw it in 202 and you saw it in many other courses.
Yeah,
If
I
you
didn't
alter
say
that-
it's not easy. Yeah, but it's lengthy. That's the point.
Yeah, you saw it in any other lectures. Let me just take the attendance if you don't mind.
تزلينك يا دكتور.
I know الحياة كلها لينكثي يا ولدي. تشوف واحد ايش لازم يكون عندكم صبر شوية يا شباب، لازم العلم تصبر شوية، تصبر
هذا
بس الجزاء من جنس العمل. الجزاء من جنس العمل يا شباب، اصبروا، هي الحياة كلها كذا اب اند داون اب اند داون الين نسقط مرة وما نزيد نطلع اب. فاصبروا شوية يعني معليش استحملوها. It's lengthy I know بس يعني الواحد شوف كم يجلس وقت قدام الموبايل وهو براوزنج وشوف السوشيال ميديا وشوف هذه وشوف هذه.
إيه بس هذا ما في
10 minutes. العوا منير شكرا عوا. الاسم صحيح منير؟ الاسم I'm pronouncing it صح؟ شكرا. الدغالبي فيصل.
يس دكتور هيل.
فيصل كيف حالك؟
الحمد لله، كيف حالك دكتور؟
الحمد لله. كيف الصوت شباب؟ كويس؟
واضح
واضح.
ممتاز دكتور.
مسعودي عبد العزيز. عبد العزيز كيفك يا عبد العزيز؟ ما سمعت صوتك اليوم عبد العزيز مرة. الملا ماجد الملا كيف حالك؟ القحطاني حسين.
يس دكتور.
حسين كيفك يا حسين؟
الحمد لله ونشكره.
منور الغرفة يا حسين.
الله يرضى عليك.
المحمدي عبد العزيز. منور المحمدي ما شاء الله بالنظارات، تقول ممثل من ممثلين هوليوود هذا. اليحيى عباس. يحيى كيفك يا يحيى؟ ان شاء الله بخير. قحطاني عبد الكريم بالقاف ولا بالقاف؟ القحطاني هنا مكتوب بالكيو معناته قاف.
ايه دكتور
بالقاف ما شاء الله. قاف صعب النطق هنا في الخليج تنطقوا قا.
ايه كذا ما وصل.
الشهري علي. الشهري علي ما شاء الله، الشهري دايما منور. الرميح هاني قائد الفريق.
يس
قائد
الله
الفريق.
يسلمك يا دكتور.
القرني علي. القرني علي. الزهراني فارس. فارس
يس موجود.
بطل فارس، البطل فارس ما شاء الله بطل. الحمدان عبد العزيز.
حاضر
عزيز. اهلا وسهلا شيخ عبد العزيز. الشريدة محمد. شباب استجيبوا الله يرضى عليكم، استجيبوا بسرعة، عندي حصة 3:30 فيها 3 ساعات محاضرة. الشريدة محمد ما هو موجود. العجمي مبارك. العجمي مبارك. أهلا وسهلا.